So in this video, we will be making a lipid file. This assumes you have a few things, a data set with at least one variable that you've determined meets our criteria, and the actual data, like from the paper or off nowhere, and also a small amount of information about that data set, which you'll see as we go along. So I am just going to share my screen. Okay, so I'll be using just a sort of random lake from southeastern Australia. I'm just hiding the floating meeting controls. There we go. Lake Killumbit, and I've got the data off NOAA. Now, to make a lipid, you will need the data in a table format. So if you've got a classic NOAA text file like I've got from here, then I find the easiest way to deal with that is to just open the text file in Excel. So here we go, I've got Excel, this is the text file. You'll see a screen like this, which is just telling Excel how it should read the text file. Generally delimited is a pretty good bet. And then when you get here, just scroll down until you see the data and check that there are lines between the data columns. You might have to choose comma or space or something else. Okay, but so here's my data. I can scroll down here, and there we go. That's all looking pretty good. Okay, now the first thing I've spotted here is that, as you know, for Hydroclimate 2K, all our time axes are in years CE, like, years, this is the year 2026, whereas this data set, the age axis is in years BP, which in this case would be years before 1950. So I'm actually going to have to edit this. This will make things easier later and make an age axis here that is in years CE. So I'm just going to call that CE. There we go. All right, so I've got my data. Now let's head over to make our lipid. So to do that, we go to the lipid verse. So that's lipid.net/playground, or you can see it appeared there. Just wait for that to load. Oh God, it's taking a while. Sorry, I don't know why my internet's so slow. Okay, well, that's loading. Just a reminder that when you're making a lipid with somebody else's data, you should always include all of the variables, if you can, if the author's made them available, even if some of them aren't hydroclimate related, like if they're a temperature record or something, or they don't pass that criteria for some other reason, that's not a problem. Later, when the data set and all its variables show up on our master QC sheet, there's actually a metadata field for that called in this compilation where we can flag that a particular variable should not be considered as part of our data set, but we're keeping all the author's original data together. Okay, so this is finally loaded. Here's the lipid playground, which is where we make lipid files. And so the first thing we need to do is to enter the data set name. And this, you can see here, it shows you the format that we should use, which is the site name and then a dot, then the layout. Oh, okay, no, that's not actually not it. This is, sorry, this is the format we use. So I've entered this earlier. This is the lake I'm doing, Lake Killumbit. So it's the site name and then the author's name and then the year. Here in created by, that will be lipid.net. And under archive type here, there's a drop-down menu that you should choose from. This is a controlled vocabulary. In this case, it is a lake sediment record. If there isn't an asterisk, and you can skip this field for now, these are also things that can be entered later on in the QC sheet. So down here under geography, to make the lipid, we do need to enter a latitude and a longitude. So it's easiest if you have this information first. So I've put that here in my working QC sheet. Let's see. So here we've got the latitude in decimal degrees, and the longitude. I've also got elevation here. You can choose the units for that. You can add a site name if you want. You don't have to. I'm going to do it just while I'm here. Kilometre. Okay, and now we get to the part where we are actually entering the data. And so we do that here. It's in lipid terminology, it's called a paleodata measurement table. And so to add a measurement table, I will click here where it says paleo O and measurement O, and that will create a measurement table. Now, the first thing you can do here is enter, if there's what the value is in your data for missing data, whether that's an NA or a -9999 or whatever. In this case, I think there isn't any metadata. And then what you need to do is to add to the measurement table one column for every column that you have in your data. So here, I'm actually going to get rid of this one. Oops, so there's, I'm not going to include the age in years BP. It's not necessary in this case, and BP is a tricky one because the P isn't always defined as 1950, as I'm sure some of you have experienced. So where's paste as values? Paste as values. There we go. So I'm not going to include that. I'm just going to include the age in years CE. So we have 4 columns: the depth, the age, this is a grain size, and lake depth. So I need to enter 4 columns. So I press this add column 4 times. 1, 2, 3, 4. So there we go. And you can see here, there's a sort of a tab essentially for each column. This lipid maker uses, it's like Python, it uses 0 indexing. So the first column is column 0, then column 1, 2, and 3. So once this has appeared, you can simply copy and paste the data in from your sheet. So here we go, I've copied that. And I will paste it straight in here. Scroll back up to the top. Okay, so there's the data. Now, you will see from what I've just done that this lipid.net, the playground, is not what I would call header aware. So it's not like, pandas or something that will cleverly recognize whether your data has column headers or not. It'll just put the values in the cells. So you see here, I didn't actually copy the column names. If I had done that, they would have included in this first row here. You have to enter those manually. Okay, so our first column here is depth in centimeters. So to enter the information for a variable, you click on its associated column. So this first column, column O, click that and it will bring up this page where you can enter metadata about that variable. So you can see it's pre-populated the archive type. Now the variable type, you have 4 options you can choose from. This is prescribed values in this drop down. There's a measured variable, inferred, we'll talk about those in a second, time or depth. So this is the depth variable. So here you can specify whether it's the bottom or the top depth of the sample. In this case, it's just depth. Units, so you see variable name, there's a drop down menu, it's the same for units. If you can, you should use a value from these menus that appear. If it's sort of grams per centimeter squared, it would look like this. So sort of rather than entering some synonym for that. So here I've got centimeters, which, there we go. And actually for depth, that's all I need to enter. Just the variable type is depth, the variable name is depth, and the units are centimeters. Okay, so once you've finished with one variable, you can either click it again and this sort of metadata entry page will disappear, or click straight on to the next variable. So see, I click this and we've come back to our columns. If I now click refresh spreadsheet, there we go. So the name and its units appear on the column header. Okay, so let's go ahead and deal with the second column. So I've just done this one. We're now up to the second one, which is age in years CE. So the variable type, this is now time. The variable name is age. this will be the same for every variable, every time axis that you put in. And the units, so the way these are described in the lipid verse is actually, it's actually years AD. So, AD and CE being synonymous. In this case, the prescribed entry for years is years AD. Okay, so that's done. I can come back here, click refresh spreadsheet, and see that we now have that column is done. Okay, and so now we have the two data variables. So here's the third column. So this variable type, I'm going to come back here. So this one is, let's have a look up here. This is, it's grain size. I just know that. I thought there was some information about that here. Is there? Variables. Oh, there you go. Okay, but what this is grains. It's actually the percentage of grains in the sediment that are larger than 63. What's that? Micrometers. Okay, so let's go back here. So the variable type is measured because this is something that has been directly measured. Other examples of measured variables would be things like delta O18 of carbonate or tree ring width or liquid wood density, anything that you've sort of measured or analysed, pollen counts, whatever. Now the variable name, so we have here grain size, but actually in this case, it's a little bit more complicated. So there's a prescribed entry here for grain size. I think I'm actually going to leave it like that. I'd have a bit of a think of this. I think I'm going to scroll down here to description. I'm going to write percentage of grains larger than, and where was it? It was 63. Yeah. Okay. I mean, if I were doing this for real, I'd have a bit more of a think about it. Maybe I'd make the actual variable name something a bit more descriptive, but for now, this will do. The units in this case are actually percent because it's percentage of the sediment that is of this particular grain size. Now, if the variable type is something that is measured, then the proxy will actually be the same as the variable. So this is still a grain size. You're going to see in a moment the case where proxy would be different to variable type, to the variable name is if it is an inferred variable. So where something has been reconstructed from something else, like for example, if there was a precipitation reconstruction based on tree ring width, then in that case the variable name would be precipitation, but the proxy would be tree ring width. Okay. In this case, though, because it's a measured variable, both the variable name and the proxy are the same as grain size. Okay, so that's all we need from there. I'm going to skip straight over to column 3, which is called lake depth. And this one actually, which I know because I've just read the paper, this is lake depth in meters, which has been inferred using a lake model from that grain size data. So this actually is an inferred variable. Now the variable name, let's see, is it water table depth? No, is there a water content? Lake volume, like area, like trend, like level? Like level? I'm gonna write lake depth here. Maybe they'll end up being converted to lake level, I'm not sure, but there we go. I'm gonna just put in lake level. The units are in meters. The proxy is actually grain size because this lake depth has been inferred from grain size. And this is a handy thing here. If you have already entered the variable from which this inferred variable has been inferred, they'll actually appear here and you can link the two. So this has been inferred from grain size. And that's telling the lipid file that this variable, lake depth, has been inferred from this other variable, grain size. Okay. So I'm going to close that, click refresh spreadsheet, and you'll see now that we have some details for each of our variables. Now, at this point, particularly if you have lots and lots of variables, it's really important to just check that you have entered the correct name for the correct column. So here we've got depth starts with 0.5, that looks good, age at 2004, grain size at 0.08, and lake depth of 13.3. Okay, good. So everything matches up fine. If you've just got a couple of variables, it's usually okay. If you're entering like biomarkers or something, you've got 20 variables, it doesn't hurt to check. Now, at this point, if if that was all the data we had, we are essentially done. It will sometimes be the case, I think often in Lake World, but also for other archives, where the authors may have published one set of data on a particular time step, so it's all in one table, but maybe another set of variables on a different time step. So an example might be where there's some discrete samples, like maybe carbonate delta 18 measurements, but also something like scanning XRF data, which is done at a much higher resolution. Now you can't enter those into the same table, of course, because we've got, the depth or the age in rows, but that all should be in the same lipid file. So the way to do that is actually to add another measurement table. Actually, that is the case for this particular lake. There's quite a few other variables that are measured on different time steps. I'm not going to bore you with it, but yeah, so we've got this data here. If we scroll down here, we can see this is add table. So I have to choose the table type is measurement table, click add table. And you can see there's a new tab that's appeared up here. So measurement table 1, click here, and then you could go through the same process again. So, put in your missing values, add some columns, and go ahead and enter your data. I'm just going to delete this now because there we go. Okay, so but in this case, we can say that I've finished this. So I've got the data, I've given it some basic information, I've entered the information that's needed to make a lipid. The last step is simply to click this button, download as lipid. It's thinking, it's asking me where I want to save this. You might have a folder for this. You'll see here it's making a file type is an LPD file. It's given it the data set name as I entered up here, which is the site name, the first author and the year. Click save. And we are done. Okay, let's see. So that's making a lipid. I hope that wasn't too chaotic, or at least it's given you a sense of what you should do. If you ever have any questions, you can feel free to ask me or Matt or Nick McKay. I think there's actually another tutorial on how to make lipids somewhere on YouTube done by Nick, so you could also watch that. Otherwise, happy data collecting.